Okay, so this is going to be a fairly long video, and I'm going to go through every example in the worksheet for Faraday's laws. You don't have to watch all of them. I'm going to do some timestamps in the description of the video so you can go straight to the example that you need help with. And I strongly encourage you to try the examples and check the answer and only watch the video if you're really stuck. So I think I have categorized the questions into 4 types. The first type is this, is when you're given the input and you need to calculate the output. And the output normally is in the form of the amount of products that the electrolytic cell will produce. So let's start with example 1. A chromium plating cell. So you know that this is electroplating. If you know that the question is using an electroplating cell, you already know that the product is chromium because it's a chromium plating cell. So I already know product is chromium, which is Cr. That's the symbol for chromium. A chromium plating cell operates with a steady current of 30 amps. So this is the current. So let's do a quick summary of the question. Current is 30 amps for 20 minutes. So that's time. 20 minutes. You're going to have to convert this time to seconds. Or maybe we should do it right now. So 1,200. I just did that in the calculator because it's too early in the morning for me to do anything in my head without a calculator. Anyway, what's the question asking? What mass? So it's asking for mass. Symbol for mass is M. A chromium. If it say chromium, it's referring to the metal and not the metal ion. Let's not go find the mass of the metal ion. So what mass of chromium is plated on the object? So the mass of chromium at the anode. Okay. Did I just say anode? The cathode. Is plated on the object at the cathode, assuming a solution containing chromium 2+ ions. All right, so what do we do here? First thing first, always determine the equation that is going to produce the product. So you need to find the equation here. And a few hints are already given to you in the question. You know that this is an electroplating process, so you know that the product is supposed to be chromium. So I know chromium is going to be the product of this equation. And I know that this is supposed to be reduction because we're talking about the product being produced at the cathode. And you know that the solution, which means that the electrolyte, contains Cr2+ ions. So the equation at the cathode to produce chromium must be Cr2+ plus 2 electrons going to Cr. So this is the equation. I know that the ion in the electrolyte is Cr2+, and I know the product is Cr. Therefore, I know that 2 electrons must be added to the chromium ions or gained by the chromium ions to produce chromium. So that's the equation. It is very important to get into the habit of writing the equation out. Once you get very good, you can skip this step, but I wouldn't recommend, for example, 1 anyway. Actually, I don't recommend at all because people always make a mistake here regardless if they don't write the equation out. So you need to find the mass of chromium. You already have the equation, so there is a relationship between the number of mole of chromium and the number of mole of electrons. So if I can find the number of mole of chromium, I can get the mass. So from here, I know that the number of mole of chromium over the number of mole of electrons, this is a 1:2 ratio. Another way of saying it is that the number of mole of chromium is 1/2 times the number of mole of electrons. Okay. So if I can work out the number of mole of electrons, I should be able to find the number of mole of chromium and then find the mass of chromium. And I should be able to find the number of mole of electrons because I have this, and I know there is a relationship between this and the number of mole of electrons. I also ran out of room, so I'm just going to go to the next slide. Time is 1,200 seconds. So we're going to go with Q. You can find the charge. Q is going to equal to I times T, which is 30 times 1,200. So we're looking at 36,000 coulombs. And if you use Faraday's laws, Q is n of electrons times F, or you can say that the Q over n of electrons is 96,500 coulombs on 1 mole of electrons. Now, if you go unknown over given, I'm just going to stick to one method. You don't have to use it. Unknown over given, the unknown that I want to find here is the number of mole of electrons. And the given, I know the charge. So given 36,000 coulombs, that is equal to 1 mole of electron for every 96,500 coulombs. And you should be able to rearrange this ratio to work out the number of mole of electrons that applies to this many charges. So if we just move the 36,000 to the other side, let me just write, okay, I'll write everything out. So n of electrons is 36,000 times 1 over 96,500, which is 0.37. So keep the exact value in the calculator, mole. So we're going back to this ratio, the number of mole of chromium. Let's just do a thing here. N of chromium is going to be a half times the number of mole of electrons. So divided by 2. So 0.19. Again, I'm using the exact value. And then you're going to determine the mass of chromium. So number of mole times molar mass. You need to check your data book, the periodic table, for the molar mass of chromium, which is 52. So times 52. All right, let's go back to C33. So I'm looking for 3 significant figures in my final answer. So 9.70 grams, correct to 3 significant figures, and that's the final answer. Example 2. So very similar to example 1, but there is one extra difference. There is one difference, and that is that you have to work out the charge of the metal ion from the information provided. So you have gold plating. So once again, I know the product is gold, or Au, solid, with a static current. So you know the current is 25.7 amps, and the time is 12 minutes, or let's convert it to seconds, 720 seconds. Give me a second. What did I do here? Oh yeah, that's fine. Okay. Using AuNO3 solution as the electrolyte. So once again, we're going to write the equation that produces the product that you have to find the mass of. Question asks for mass of gold. Okay. Now, there is while people are tempted to look at the electrochemical series to determine the half equation, and if you look back at example 1, you could actually get this equation from the electrochemical series. There is an equation for chromium there. However, I would strongly advise against doing that, because a lot of the times the equation that is listed in the electrochemical series will not apply to your element here. And this is an example of that. If you look at the electrochemical series, you're going to see this equation for gold. And the equation for gold is Au plus electrons going to Au. This is from the electrochemical series, but you cannot use this equation for this question because the gold ion that you have in your electrolyte does not have a charge of 1 plus in this question. So this is going to be an issue for any transition metal that can potentially have more than one type of ion. It is more useful and more accurate to just look at the type of ion that you have in the electrolyte rather than use electrochemical series, because a lot of the time will be wrong. And then some other times you don't even have that metal ion in your electrochemical series anyway. So if you look at this AuNO3, I expect you to know the charge of nitrate, which is 1 minus. So if you need 3 nitrate to neutralize the ionic compound, the charge of the gold ion in this case will be Au3 plus. So the equation is Au3 plus going to Au, which means that I need 3 electrons to balance the charge. So this is the equation, and it will give you a ratio between number of mole of gold to the number of mole of electron, and that's a 1:3 ratio, which is another way of saying that the number of mole of gold is a third the number of mole of electrons. Okay, everything else is very similar to example 1. So I'm going to find the charge again. So Q is IT, which is 25.7 times 720 second. I'm just typing in the calculator here. Okay, 18,504 coulombs. And then this is, we need to find the number of mole of electrons. So number of mole of electrons over 18,504 coulombs is equivalent to 1 mole for every 96,500 coulombs. Again, you don't have to use this method. You can use whatever method you want. To be fair, this is not my go-to method, but a lot of people find it easier to understand. It's very hard especially when we talk about calculations in chemistry, because there's so many different ways to explain the same thing, and it's hard to pick a method that everyone would get and at the same time be consistent in your explanations. I'm just going to go with unknown over given, I think. So this is a number of mole of electrons, so from there you should be able to work out the number of mole of gold, which is a third of this, divided by 3, and so 0.0639 mole, and I'm going to get the mass, which is number of mole of gold times molar mass. Okay, what is gold? I should know 197 grams per mole is gold. Alright, and go back 3 significant figures for the final answer. So 12.6 grams. I hope I don't make a calculation error, but maybe I did. Alright, so that's example 1 and 2.